this problem, we want to find the critical numbers and open intervals which function is increasing or decreasing. So we've got f of x is equal to the cube root of x squared minus 16. Well, to begin with, we know to find a derivative, we don't want it in radical form. So I'm going to rewrite this as x squared minus 16 to the 1/3 power. Now, whatever number's in the slot right here, that's called your index. That always goes in your denominator. And then you put a 1 up here. Okay, so step 1. Find our derivative. Now, this is going to be the chain rule, specifically a general power rule. We got parentheses to a power. If you got parentheses to a power, you take your power, put it out in front. What's inside the parentheses remains as is. Lower your power by 1. And then you multiply it times the derivative of what's inside your parentheses, which is the x squared minus 16. So that gives us 1/3 x squared minus 16. 1/3 minus 1 gives us negative 2/3. The derivative of x squared minus 16 is 2x. Now we want to put this into a single fraction. So 2x I'll put up on top. 3 is already down in the denominator. And this x squared minus 16 and the negative 2/3 I want to take down below. And it becomes x squared minus 16 to the positive 2/3. Okay. That's our derivative. Now to find our critical values. If you got a single fraction, and that's what you should try to get, if you got fractions at all, work at getting a single fraction. Then you're going to set your top part equal to 0, your numerator, and you set your bottom part equal to 0, your denominator. Now here we'll divide both sides by 2, and we get x equals 0. Now here, remember if you have a, oops, I didn't set that equal to 0. Remember if you have a number out in front, you got a power, you drop all that, and you just set what's inside your parentheses equal to 0. Now I'm going to use the square root property on this, so I'll take negative 16 to the right side, and it becomes a positive 16. The square root property says we drop our squared, and we put a plus or minus square root around the other side. And 16 is 4 times 4, so this gives us plus or minus 4. Okay, now let's go back up to our derivative. Again, these are a little tricky to enter. If you ever have more than a single number or a single variable on the top or bottom of your fraction, you need to put parentheses around it when you plug it in your calculator. So I want parentheses around the top, and I also want parentheses around the bottom. Now if you ever have an exponent that has more than a single number or a single variable in it, like this 2/3, you want to put parentheses around it. So when I plug it in, I want to put parentheses around 2/3. Let's go ahead and plug this in our calculator and get ready. Oops. Okay, so I'm going to go to my y equals, clear. Now work with my top part. So I want beginning parentheses 2x, closing parentheses. So beginning parentheses 2x, closing parentheses, divided by parentheses around the bottom. That's my beginning parentheses right there. Then 3, and then another beginning parentheses. That's this one right here. X squared. So I do my x key, x squared, minus 16, close parentheses, caret for the exponent, and then we want 2/3, but we want to put a beginning parentheses. So you do beginning parentheses 2 divided by 3. Now if you want to put the closing parentheses at the very end, you can. TA3, TA4 doesn't require it. Now let's go check to make sure our table setup is correct. So do second window, and your independent should say ask. If it doesn't, then down arrow to that line, right arrow, put your flashing cursor on the ask, and press enter 1 time. And then do a second mode to exit out. Okay, now we got that part ready. Let's build our table of intervals. Okay, so our smallest critical number, critical value is -4. Our next one's 0, and then we got 4. And clear over here is negative infinity. Clear over here is positive infinity. Now we want to pick test cases. We want to choose x values between negative infinity and negative 4. It doesn't matter what you pick one, I guess I should say. We'll pick negative 5. You could also pick negative 6, negative 7. Here we want to pick a test case between negative 4 and 0, like negative 1. And over here we want to choose something between 0 and 4, like 1. And over here we want something greater than 4, between 4 and infinity, like 6 or 7 or whatever. Could be 5. So those are our test cases. Now keep in mind, we just put our derivative in y equals. So now, and we checked our table setup, and it's correct. So now we're ready to go to our table. And what we're going to be doing is we're going to be plugging each one of those test cases into our derivative. And you could do it by hand, or you could use your calculator. So I come over here, I'll do a second graph to go in the table. I already have some numbers there. I'll keep pressing delete until they're gone. Put in negative 5, enter, negative 1, enter, 1, enter, and 6, enter. Now you see negative 5 gives us a negative number. It's negative, so this is decreasing. The negative 1 right here, or the negative 1 right here, gives us a negative number, so it's decreasing. The 1 gives us a positive number, so it's increasing. And the 6 gives us a positive number, so this is increasing. Okay. So our answer is it's decreasing from negative infinity to negative 4, and it's decreasing from negative 4 to 0, and then it's increasing from 0 to 4, and then it's increasing from 4 to positive infinity. Now where I'm getting those numbers is across the top here. That's where you get these intervals. And that's our answer. That's kind of a weird looking graph, isn't it? Decreasing, decreasing. Let's graph it, just see what in the world that looks like. So I go to y equals, clear, got the cube root, so we'll go to our math menu, and we'll choose the fourth one. That's cube root. So I press 4 to choose it. And then we want x squared minus 16. So x, and then my x squared minus 16, and then graph. Sure enough, decreasing to negative 4, then decreasing to 0, and then it's increasing to 4, and then it's increasing some more on up. So that is correct. Those are our answers.